The wind triangle. Correct and wrong plotting gives the same output. Wrong way of plotting, but gives the correct result. For example, the vessel is going north as represented by the red arrow, and the wind indicator shows 45 degrees on the starboard side, represented by another red arrow. Then, using the ship's speed, measure your E to R, which is your own ship's course and speed, represented by the blue line. Using the relative wind speed, measure a line 45 degrees to starboard, also represented by a blue line as shown. Then draw a line that touches the tips of the two blue lines as shown. Along this line, the true wind speed will be the measurement from the tips of the two blue lines. Then drag or transfer this line using a pair of triangles or a parallel ruler to the center. That will be the true wind direction, and remember that the wind direction is measured from where it is coming from. Although it is the wrong way to plot the wind triangle, this method still produces the correct true wind direction and speed. And this is the most common method done on board. Because it seems easier to plot. The correct way of plotting. In the same example, the ship is going north represented by the red arrow. Plot the own ship's course and speed along the red arrow and label it E to R, represented by the blue line. Remember that the wind indicator shows 45 degrees to starboard. The effect of the relative wind direction, which is relative to your ship, is that it is acting against your starboard bow, so the direction of the relative wind should be measured from R and going reciprocal to 45 degrees relative, and that is 225 degrees relative, because the wind is blowing to 225 degrees relative from 45 degrees relative, represented by the red arrow. Using the relative wind speed, measure your relative wind R to W along this line, represented by the blue line. Label it R to W. Then draw a line passing from the center of the compass rose and touching the tip of the relative wind at W, represented by a red line, and that is your true wind direction. Remember that the wind direction is measured from where it is coming from and not where it is blowing to. Here, the true wind direction is at 103 degrees true. Along this line from the center to W, measure the true wind speed. In radar plotting, E to R is own ship, R to W is the relative wind, and E to W is the true wind. This is the correct way to plot the wind triangle, but only a few do this method. What is the reason why the two methods produce the same result? That is because the two triangles formed have the same congruent angles on both sides. Congruent angles. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. Therefore, side C to A is equal to side D to F. Example: the ship's speed is equal to 13 knots. The course is 90 degrees true. The wind indicator shows the relative wind direction is 40 degrees on the port side. Relative wind speed is 10 knots. Required: 1. True wind speed, and 2. True wind direction. Here, we will use again the compass rose. But you can also use other methods, such as using a radar plotting sheet. From the given, draw a line from the center of the compass, rose to the course of 90 degrees, represented here by the red arrow. Measure the ship's speed using the latitude scale on the left, represented by the blue line. You can use any scale that is appropriate for measuring the speed. Then transfer it to the center along the 90-degree line, normally by using the divider when on the chart table on board. This is your own ship vector that will be labeled E to R. Draw a line corresponding to the relative wind, which is 40 degrees on the port side. Since the effect of the wind is acting on the port bow of the ship, the relative wind vector is measured from R, represented by another red arrow. Measure the relative wind speed using the latitude scale and transfer it to the wind vector line as shown here. That will be the R to W relative wind speed. Draw a line passing through the center and touching the tip of E to W line. That will show the true wind direction shown here by a red arrow. Remember that the wind is measured from where it is coming from and not where it is going. Label the triangle E to R, R to W, and E to W. You can label these earlier. The true wind direction is approximately 323.7 degrees and rounded off to 324 degrees here. Then measure the E to W line using the latitude scale, and this will be the true wind speed. Here, I use the latitude line near the E to W line, but in actuality, measurement is done normally by the divider on board. The true wind speed is 8.8 knots approximately. Conclusion: this lesson is to show you how to plot the wind triangle to obtain the true wind direction and speed. You can use both methods when on board, but in school, you must use the correct method so that it will agree with the theory, especially using the radar plotting sheet. Remember that when you use the wrong method, you cannot show the relative wind because it will be labeled as E to W. Although you will obtain the same output, there is something wrong with your triangle, and some knowledgeable masters might ask you to label your triangle, and it would be hard to explain. Always remember that it is better to use the correct method. The E to R line represents the ship's course and speed. The R to W line represents the relative wind direction and speed obtained by the wind indicator, which could be digital, or analog, such as the wind vane and anemometer. The E to W line represents the true wind direction and speed. Happy learning, everyone! See you in the next video!